लेन्स लको बादमा हाम्रो अर्को टपिक छ मेथड्स अफ क्रिएटिङ इन्ड्युस्ड इएमएफ। हामीले चाहिँ इन्ड्युस्ड इएमएफ कसरी क्रिएट गर्न सक्छ। फर्स्ट छ बाई चेन्जिङ द स्ट्रेन्थ अफ म्याग्नेटिक फिल्ड बी भेक्टर। अर्को छ बाई चेन्जिङ द एरिया ए अफ द लुपर सर्किट। अर्को छ बाई चेन्जिङ द रिलेटिभ ओरिएन्टेसन थीटा अफ द field B vector and area vector A vector. Faraday's Lens law, it can be stated as the EMF induced in a coil of n turns is given by the negative of the rate of change of magnetic flux linked with its turn. So we can also write E equals to minus d phi by dt. Our important topic is induction or inductance. The phenomena according to which opposing EMF is induced in a coil or circuit has a result of change in electric current or magnetic flux linked with the same coil or the neighboring coil is called induction. जसको मतलब चाहिँ electric current or magnetic flux change हुँदाखेरि चाहिँ एउटा opposing EMF चाहिँ induced हुन्छ in a coil within the same coil or neighboring coil. त्यसलाई नै भन्छ induction. It plays the same role as inertia does in mechanics. That's why induction is also known as electrical inertia. It is of two types. Induction दुईटा types को छ. We all know एउटा हो self induction अर्को हो mutual induction. Self induction भनेको के हो भन्दाखेरि the phenomena according to which an opposing induced EMF is produced in a coil as a result of change in current or magnetic flux linked with the same coil. यहाँ चाहिँ same coil मा नै भएको कारणले गर्दाखेरि चाहिँ यसलाई self induction भनिन्छ। यो phenomena चाहिँ हेनरी in 1832 मा डिस्कभर गरेको थियो हेनरीले। When an electric current is passed through a coil, magnetic flux is set up around it. When the current flowing through a coil is changed, the flux link with it changes and an induced EMF is produced in the coil. The induced EMF is called self-induced EMF and phenomena is called self-induction. Coefficient of self-induction. Coefficient चाहिँ कस्तो हुन्छ भन्दाखेरि consider a coil connected to a battery B and a tapping key K as shown in figure. यो फिगरमा शो गरेको जस्तै एउटा ब्याट्री र एउटा की चाहिँ कनेक्ट गरेको छ। Let at any instant t the current flowing through the coil be I. Since magnetic flux linked with a coil at any instant is proportional to the current flowing through that coil at that instant, that is phi is directly proportional to I, and your proportionality constant हटाउनको लागि हामीले L लगाइदिएपछि हाम्रोमा आउँछ equation 1 where L is proportionality constant called coefficient of self-induction of a coil. If I equals to 1 ampere, then L equals to phi. Thus, the coefficient of self-induction of a coil is numerically equal to the magnetic flux linked with the coil when a current of 1 ampere flows through it. According to Faraday's law of electromagnetic induction, the induced EMF produced in a coil due to changing magnetic flux is given by यो हामीले अघि नै निकालिसकेको थियो E equals to minus d phi by dt or E equals to minus dli by dt. यो phi को बदली हामीले li लगाइदियो or E equals to minus l di by dt. Equation 2 बनायो. The negative sign shows the opposing nature of induced EMF. यो negative sign ले चाहिँ opposing nature of induced EMF बुझाउँछ. If di by dt equals to 1 ampere by 1 second, then E equals to minus L. Thus, the coefficient of self-induction of a coil can be also defined as the induced EMF produced in the coil when a current of 1 ampere flows through it in 1 second. जब चाहिँ 1 second मा 1 ampere current flow हुन्छ त्यतिखेर चाहिँ भनिन्छ हामीले unit. The SI unit of self-induction or coefficient of self-induction L of a coil is Henry. SI unit दियो थियो भने CGS unit of self-induction is ab Henry. 1 Henry equals to 10 to the power 9 ab Henry. mutual induction भनेको the phenomena according to which an opposing induced EMF is produced in one coil as a result of change in current or magnetic flux linked with the neighboring coil is called mutual induction. एउटा कोइलमा चाहिँ म्याग्नेटिक फ्लक्स चेन्ज भएकोले गर्दाखेरि अर्कोमा अपोजिङ इन्ड्युस EMF प्रोड्युस हुँदैछ, यसलाई नै भनिन्छ म्युचुअल इन्डक्सन. When an electric current is passed through P coil, यो P मा चाहिँ जब इलेक्ट्रिक करेन्ट पास गर्छ, the magnetic field is produced, which produces magnetic flux through S coil. And when the electric current flowing through P coil is charged, the magnetic flux linked with S coil also get charged, and opposing EMF is produced in it. The EMF produced in S coil is called mutual induced EMF, and the phenomena is called mutual induction. Coefficient of mutual induction. Since the magnetic flux linked with S coil at any instant is proportional to the electric current flowing through P coil at that instant, that is phi is directly proportional to I, and your proportionality constant हटाउनको लागि हामीले m लगाइदियो भने phi equals to mi. Question 1, where m is proportionality constant called coefficient of mutual induction of two coils. If I equals to 1 ampere, then m equals to phi. Thus, the coefficient of mutual induction of two coils is numerically equal to the magnetic flux linked with one coil when a current of 1 ampere flows through the neighboring coil. According to Faraday's law of electromagnetic induction, the induced EMF produced in S coil due to changing current or magnetic flux through P coil is given by E equals to minus d phi by dt as usual, or E equals to minus d by dt mi, phi को बदले हमने mi लगाइदियो, or E equals to minus m di by dt. यहाँ minus किन भन्दाखेरि the negative sign shows the opposing nature of induced EMF. हाम्रो अर्को इम्पोर्टेन्ट टपिक छ इडी करेन्ट. इडी करेन्टलाई फोकल करेन्ट पनि भनिन्छ. The current induced in the body of a conductor due to a change in magnetic flux linked with the conductor are called eddy currents. These currents are also known as focal currents. The magnitude of eddy current is given by I equals to induced EMF by resistance, that is A by R. But E equals to minus d phi by dt यो हामीलाई याद छ. Therefore, I equals to minus d phi by dt by R, where R equals to resistance of the conductor. The direction of eddy current is given by Lenz's law or Fleming's right hand rule. Experimental demonstration, which experimentally कसरी demonstrate गर्यो भन्दाखेरि, hold a light metallic disc at the top of cross section of electromagnetic connected to a source of AC as shown in figure above. यो फिगरमा देखाएको जस्तै. When AC is situated on the disc D is thrown up into the air. This is because of production of eddy current in the disc. As current through the solenoid or coil increases, the magnetic flux around the axis of the solenoid also increases. As a result, magnetic flux linked with the disc increases, due to which induced current called eddy current are produced in the disc and magnetize it. If the upper end of the solenoid initially acquires an polarity in accordance with Lenz's law, thus the force of repulsion between the two throws the disc up into the air. जस्तै यो डायग्राममा छ, यहाँ डिस्क छ, यो डिस्क चाहिँ is thrown into the air किन भन्दाखेरि चाहिँ एडी करेन्टले गर्दाखेरि. एप्लिकेसन, एडी करेन्टको एप्लिकेसन केमा हुन्छ भन्दाखेरि अथवा यसका एडभान्टेजेस चाहिँ इलेक्ट्रोम्याग्नेटिक ड्याम्पिङ, इलेक्ट्रोम्याग्नेटिक ब्रेक्स, इन्ड्युस्ड or induction furnace, speedometer, inductothermy. The disadvantage चाहिँ के छ भन्दाखेरि they oppose the relative motion लाई oppose गरिदिन्छ. They involve loss of electric energy in the form of heat. They reduce the life of electric devices हरूलाई छिटो बिगाडिदिन्छ एडी करेन्ट बेसी भयो भने. And the eddy current लाई चाहिँ हामीले कसरी घटाउन सक्छ भन्दाखेरि they are minimized by using laminated cores. These laminations are lightly reverted to form a core called laminated core and are parallel to magnetic flux. Our next topic छ mutual induction of two long solenoid. दुईटा long solenoid को बीचमा चाहिँ mutual induction चाहिँ कस्तो प्रकारले हुन्छ भनेर अनि यो चाहिँ experimentally हेर्यो भने consider two long solenoid S1 and S2. जस्तै यहाँनिर S1 यो भयो भने S2 यो हुन्छ. Let each of length L अनि यसको length चाहिँ L छ रे यो दुईटा solenoid को. Let N1 equals to number of turns per unit length of solenoid S1. यो S1 को number of turns चाहिँ N1 लियो भने यसमा current pass हुँदै गरेको I1 लिन्छ, strength of current in S1. अनि N2 number of turns per unit length of solenoid S2. S2 को number of turns S2 भनेपछि यहाँनिर. अनि I2 चाहिँ strength of current in solenoid S2. The solenoid S1 is closely wound over the solenoid S2. मतलब यो दुईटा यस्तो खालको arrangement मा छ. So that both have the same area of cross section A as shown in figure. The magnetic field B1 at any point inside solenoid S1 due to current I1 is B1 equals to mu naught N1 into I1, equation 1. Therefore, magnetic flux linked with each turn of solenoid S2 equals to B1 into A, which is equals to mu naught into I into I1 into A. Mutual induction त्यस्तो थियो भने self induction of a long solenoid चाहिँ कस्तो हुन्छ भन्दाखेरि consider a long solenoid of length L, number of turns and an area of cross section A in small n is the number of turns per unit length of solenoid, then n equals to n into L. Question 1. When an electric current I is passed through the solenoid, the magnetic field produced inside the solenoid is almost uniform and is given by B equals to mu naught Ni. Question 2. Where mu naught equals to permeability of free space. Therefore, magnetic flux linked with each turn of solenoid equals to BA equals to mu naught N I into A. Equation 3. Total magnetic flux linked with the entire solenoid is phi, which is equals to flux with each turn into total number of turns, that is phi equals to mu naught N I A into N into L. Phi equals to mu naught I N square AL. Question 4. If L is the coefficient of self-inductance of the solenoid, then यो हामीले अघि निकालेको छ phi equals to Li भनेर equation 5 गर्यो. अन्त from equation 4 and 5 Li equals to mu naught N square IAL, which is equals to L equals to mu naught N square L by A, जसमा चाहिँ I र I काटिन्छ. हाम्रोमा अर्को टाइपको म्युचुअल इन्डक्सन छ जसमा चाहिँ दुईटा कोइल चाहिँ कन्सेन्ट्रिक छ. म्युचुअल इन्डक्सन अफ टु कन्सेन्ट्रिक कोइल्स जसमा चाहिँ यो भित्र एउटा भयो बाहिर एउटा भयो. If I current flows through the coil C2 of radius R2, then magnetic flux linked with the coil C1 is given by यो coil C1 भयो, यो C2 भयो, यसको radius R1 भयो, त यो ठुलो radius R2 भयो, यो बिचको origin अन्त एउटा I यहाँ current pass हुँदैछ. Phi B equals to BA. Phi B equals to mu naught by 4 pi into 2 pi I by R square into pi R square. And the यो काट्यो 2 pi र 4 pi काट्दिँदाखेरि हाम्रोमा उब्रिन्छ mu naught pi into R1 square I by 2R2. Equation 1. But phi B equals to MI यो हामीले अघि निकालेको थियो, त्यसै कारण यसलाई equation 2 गरिदियो. Comparing equation 1 and 2 we get mu naught by R1 square I by 2 pi R equals to MI. Therefore, M equals to mu naught by R1 square by 2R square. Where phi 2 भनेको flux with each turn into total number of turns, and phi 2, therefore phi 2 equals to mu naught n1 I1a into n2l जसमा चाहिँ हुन्छ mu naught n1 into n2 I1al question 3 but magnetic flux phi2 link with S2 due to current I1 in S1 is phi2 is directly proportional to I1 question 4 and phi2 your proportionality constant not on the m I1 the 5 power equation where m equals to coefficient of mutual induction of two solenoid S1 and S2 from 3 and 5 m I1 equals to mu naught n1 n2 I1al remember your last achieve mutual inductance for coaxial solenoid of same length यहाँ चाहिँ के हुन्छ भन्दाखेरि coefficient of mutual inductance for two coaxial solenoid of same length S1 inner solenoid भयो यो भित्रको solenoid भयो S2 outer solenoid of radius 2 यो ठुलो solenoid त्यसको भित्र एउटा सानो solenoid छ जसको radius हामीले R1 र ठुलोको R2 लिएको छ N1 equals to N1 by L number of turns per unit length in S1 similarly N2 equals to N2 by L equals to number of turns per unit length in S2 when current I2 is passed through outer solenoid S2 then flux link with inner solenoid is जब पनि हामीले solenoid S2 मा चाहिँ current pass गर्छ त्यसरी नै flux link हुन्छ inner solenoid मा जुन चाहिँ हुन्छ phi1 equals to m12 into I2 m12 भनेको mutual inductance of solenoid S1 with respect to S2 also phi1 equals to n1 b2 a1 equation 1 b2 भनेको m into f due to S2 so b2 equals to mu naught n2 into I2 a1 भनेको area cross sectional area or cross sectional area that is a1 equals to pi r1 so equation 1 becomes phi1 equals to n1l mu naught n2 into I2 pi r1 square also phi1 equals to m12 into I2 so m12 into I2 equals to mu naught n1 into I2 l pi r1 square I2 काट्दाखेरि हाम्रोमा उफ्रिन्छ m12 equals to mu naught into n1 into n2 pi r1 square l similarly when current I1 is passed through solenoid S1 and flux link with S2 is हामीले similarly त्यसरी नै निकाल्नु पर्यो भने phi2 equals to n2 b1 a1 phi2 equals to n2l mu naught n1 into I1 pi r1 square किन भन्दाखेरि b1 equals to mu naught into n1 into I a1 भनेको एरिया हाम्रो हुन्छ pi r1 square and phi2 equals to m21 into I1 m21 into I1 equals to mu naught n1 into n2 I1l pi r1 square m21 equals to mu naught n1 into n2 pi r1 square l that is m21 equals to m12 equals to m if a medium of relative permeability mu r had been present the mutual inductance would be m equals to mu r into mu naught n1 into n2 pi r1 square l into हाम्रो coefficient of mutual inductance for coaxial of solenoid of same length को लागि अनि हाम्रो यो भिडियोको एउटा लास्ट अनि इम्पोर्टेन्ट टपिक छ AC generator electromagnetic induction को अनि AC generator भनेको के हो भन्दाखेरि AC generator is a device which converts mechanical energy into electrical energy अनि यहाँ तकै कुरा हो अनि यो चाहिँ यसको प्रिन्सिपल चाहिँ के हो भन्दाखेरि इट वर्क्स अन द प्रिन्सिपल अफ इलेक्ट्रोम्याग्नेटिक इन्डक्सन जस्तै हाम्रो टपिक इलेक्ट्रोम्याग्नेटिक इन्डक्सन थियो त्यसको प्रिन्सिपलमा चाहिँ हामीले एसी जेनेरेटर एज अ एक्जाम्पल लिन सक्छ अनि एसी जेनेरेटर कसरी बनेको हुन्छ यसमा कुन पार्ट्स हुन्छ भन्दाखेरि एउटा हुन्छ आर्मेचर कोइल इट कन्सिस्ट अफ लार्ज नम्बर अफ कपर वायर wound over soft iron core. Soft iron core is used to increase magnetic flux. Field magnet huncha. Field magnets are used to apply magnetic field in which armature coil is rotated with its axis perpendicular to field lines. अर्को हुन्छ slip rings. Slip rings are used to provide movable contacts of armature coil with external circuit containing lead. Brushes. Brushes are the metallic pieces used to pass an electric current from armature coil to the external circuit containing load. जस्तै यहाँनिर डायग्राम प्रिपेयर छ, यो भयो आर्मेचर कोइल, अन्त यो स्लिप रिङहरु यहाँनिर छ, ब्रश भयो, त्यहाँदेखि यो म्याग्नेटिक फिल्ड भयो, B1 and B2 equals to carbon brush, B1 र B2, S1 and S2 equals to slip rings, or R1 and R2 equals to slip rings. अनि यो यसको थ्योरी अथवा वर्किङ प्रिन्सिपल चाहिँ कस्तो हुन्छ भन्दाखेरि, when the coil is rotated with a constant angular speed omega, the angle theta between the magnetic field B vector and the area vector A vector of the coil at any instant t is theta equals to omega t, assuming theta equals to 0 degree at t equals to 0 degree. As a result, the effective area at the coil exposed to the magnetic field lines changes with time. The flux at any time t is phi b equals to ba cos theta, theta equals to omega t, theta b equals to ba cos omega t. From Faraday's law, the induced EMF for the rotating coil of n turns is then E equals to minus n d phi by dt equals to n ba d by dt into cos omega t. Thus, the instantaneous value of the EMF is E equals to nba omega sin omega t. nba omega equals to E naught. E naught भनेको big value of EMF, E equals to E naught sin omega t. The direction of current changes periodically and therefore the current is called alternating current. And त्यसै कारण यसलाई alternating current भनिन्छ. Omega equals to 2 pi t, which is equals to 2 pi nu. So E equals to E naught sin 2 pi mu into t. So हामीले सबै इम्पोर्टेन्ट टपिकहरु प्राय हामीले कम्प्लिट गर्यौं, कभर अप गर्यौं. त्यसै कारण कन्क्लुजनमा आउँदाखेरि चाहिँ हामीले के पाउँछ भन्दाखेरि, from this experiment Faraday concluded that whenever there is relative motion between a conductor and a magnetic field, the flux linkage with a coil changes, and this change in magnetic flux induces a voltage across a coil. These laws are called Faraday's laws of electromagnetic induction. And electromagnetic induction को application चाहिँ के छ भन्दाखेरि, electromagnetic or magnetic induction has many applications like generation of electricity. A generator converts mechanical energy into electrical energy. Tape recording and playback, microphones, inductors, transformers, device like electric motor, etc. अनि यसको एडभान्टेजेस चाहिँ के छ भन्दाखेरि, AC or DC electrical power can be generated using electromagnetic energy source, eliminates the need of an external electrical source to generate electrical power, inexpensive, lightweight, no need to external electrical source to generate electrical power. The disadvantage चाहिँ के छ भन्दा, no control over field strength, magnetic particles attracted to poles, heat up very fast, takes a lot of energy to use. If cranked up to high, it could be dangerous. The rest को disadvantages हरु हामीले कभर अप गर्न सक्यो भने यसको एडभान्टेजेस बेसी छ अनि यसको मार्केटमा युज पनि बेसी छ. अनि हामीले यसरी नै इलेक्ट्रोम्याग्नेटिक इन्डक्सन कभर अप गर्यौं यो भिडियोमा.